Okay, nagyoyo na po ko. So remember your halogen before in your alkenes, now react with alkenes with an addition reaction now in the presence of a catalyst no, to form your alkanes. No? So alkanes can also react with halogens. In this case, alkanes before, sorry, loading. Alkenes in your chapter 8 reacts with your halogens, of course, to form also your alkyl halides. But the mechanism for that is the addition reaction, electrophilic addition reaction, and your nucleophile again is your nucleophile is your alkene. Okay, it's a homolytic, it's a heterolytic bond formation. In this case, alkanes instead of alkene can react with your halogen to form your alkyl halides. But the mechanism behind is what we call as again radical halogenation. So in the process, actually, we use a radical to form a bond. Your alkene, your halogen will form a bond to your alkene to form an alkyl halide via radical formation. So a halogen atom replaces one or more of the hydrogen atoms of the alkane to form your alkyl halide, and your hydrogen halide is your byproduct. And to do that, this reaction will like gibutang ni koan, but this usually occurs in the presence of heat and light. I have two other conditions here na siya heat and light because we form a radical. No, to form a radical, always, of course, we always use heat or light, UV light. Okay, so dapat na ni siya heat and light conditions. So nara. So an example, you have, for example, methane. Now you have your chlorine gas in the presence of heat and light. You can actually produce your chloromethane here, and you have another mole of that. Another mole of your chlorine can actually produce your another alkyl halide, not two chlorine atoms attached to your carbon, and further reaction actually produce this until all the carbon atoms or the hydrogen actually are being substituted, and you actually get 4 moles of this. No? So in this kind of reaction, you notice that we are not selective in the formation of our alkyl halides. So this kind of halogen substitution, it's not very selective again, and if you want to produce one halogen over the other, we must always use an excess of our alkane, excess rather than that, so that we can control the reactions. But in normal laboratory setting, they don't normally, if they want to prepare, chemists want to prepare an alkyl halide, they usually don't start with this, or don't usually use this kind of reaction because this is not very selective. Couldn't control. In fact, for example, in the preparation of our chloromethane, chloromethane, can be, meaning its formation can be rather maximized, and the formation of the other alkyl halides like CH2Cl2, dichloromethane, CHCl3, and carbon tetrachlorides being minimized by if you use a large excess of this in the reaction mixture. The reason is that the number of collisions with your halogen and your you have an excess of methane will increase, and you actually form a lot of this rather than the other one. Okay, so that will be your starting material. So again, in the kind of reaction, in the halogenation reaction of our alkanes, halogenation reaction, there's always actually this lack of selectivity. So for example, in halogenation or chlorinization reaction, in this case, this is very unselective. Chlorine is relatively unselective. It does not discriminate greatly among the different types of hydrogens. So for example, here you can have your isobutane, another alkane, the presence of your halogen and light, and you can substitute your hydrogen here in this case, or you can substitute your hydrogen here. Okay, and you see that there is greater number of hydrogen here. You actually produce a greater yield for isobutyl chloride here than your third butyl chloride here. And then the other one is polychlorinated products, CL. So because alkene coordinations usually yield a complex mixtures of products, they are not useful as synthetic methods in the goal of preparing alkyl chloride. An exemption is when we use an alkane whose hydrogen all atoms are equivalent. For example, if you use neopentane, you have carbon here, CH3, 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 all of the carbon are equivalent. The CH3, at least the CH, no, are equivalent. In this case, you only produce one kind of alkyl chloride here. So this is just an exemption. If you use a cycloalkane, which is symmetric, okay. Bromine, for example, if we compare to bromine and chlorine, is generally less reactive toward alkanes than chlorine, and bromine is more selective in the site of attack when it does react. So it's less reactive, but it's more selective. So if you're using bromine. So the mechanism of the reaction, no? So for the mechanism of the reactions, I have time. Let's just talk about the mechanism and then we'll end our discussion. So the mechanism, you have your, for example, your alkane and your halogen, again, to produce your alkyl halides and a mixture of all other alkyl halides. Now, several experimental observations help in understanding the mechanism of the reaction. Number one, of course, this reaction is promoted by heat or light. Without that, we cannot actually produce a radical. We can look at the mechanism later. And methane and chlorine do not react at room temperature. So the condition, this kind of reaction, we always indicate it's under UV or under light. And the light promoted reaction is highly efficient, and a relatively small amount of light photons actually permits the formation of a large amount of chlorinated products. So let's look at the mechanism of this radical formation. The first one, now for example, you have your methane, the simplest alkane, to react with chlorine in the presence of heat and light, and produce your alkyl halide. So the first one is the chain. First step of the mechanism is the chain initiation step. We have already discussed this one. It's a homolytic bond cleavage, and you produce your radical, your chlorine dot, your chlorine radicals. So this one is halogenization. The second one is once you have your halogen radical, your halide radical rather, okay, then it will abstract the hydrogen from your alkane, okay, to produce to use a homolytic bond formation here, and you produce another alkyl radical. Once you have your alkyl radical, then it can react with another chlorine and to produce your chlorine dot again here. So you have your CH3Cl here. Okay, and then your chlorine dot. And the last one is you have, this is the third step, it's the halogen abstraction. It's where you can find your, or you can produce your alkyl halides. This is in the third step. The fourth step is the termination. Once you have your alkyl radical and another radical, then these two can actually terminate the step. No? So what causes the chain reaction to terminate? Why does one photon of light does not promote the chlorination of all the other methane molecules? We know that this does not happen because we find that at low temperature, continuous irradiation is required for the reaction, or the reaction slows down. So the answer to this is the existence of the chain terminating steps. Eventually, this kind of reaction will actually terminate. Now, when two radicals combine with each other, the reaction will be terminated. Another thing, like if you have your alkyl radical, it can react with another chlorine radical or halogen radical to produce your alkyl halide, or it can react, the termination can actually react with another alkyl radical na kaning formed ani niya, kani in step 2, no? So, pag kani siyang alkyl radical will react with another radical of this for this step to be terminated. In this case, you produce another alkane, or the halogen radical and another halogen radical to produce back your halogen. So you have your side reactions, no? Your side reactions are multi-halogenated byproduct formation. So once you have your, for example, iba naka-form naman ta aning kani, step 2, ay kani, step 3 rather, once you have your alkyl halide, no? Your alkyl halide can further react with another radical to form your another radical, alkyl halide radical, and it further reacts with another chlorine to produce a dichloromethane here, and can actually continue with this process. You can start again with this one. Can you repeat this one and react with another radical? Can you produce with another radical? And what happens is that you produce another dot. But it replaces with Cl, and then you react with another chlorine and you produce until you substitute all the hydrogen of your chlorine. Okay, that's how the reaction occurs. So question, and methane is chlorinated among the products found or traces of chloroethane. How is it formed? Chloroethane. How may chloroethane? 1, 2, 3. Add this one. So you have your ethane here. Once you produce your ethane, okay, this is one of the termination step. Once you produce your ethane, actually, dirita, it can react. You have your ethane here. There is a termination step. Pag naapay mabilin nga radical, it can actually react with another chlorine dot to produce your chloroethane. Or you can have your this is for ethane. No? Again, so you have your ethane. Once you produce your ethane, katong sa mention, the question is, how do you find chloroethane? So you have your ethane here, you react with another chlorine that produce your chloroethane. Okay, so then you can have your practice problems here. 10.2, and I'll send that. So next meeting, we will talk about the halogenation of higher alkanes, and then we'll finish chapter 10, and then we'll proceed to another chapter. Do you have questions? Okay, so that ends our session for today. And if you have questions regarding your exam, you can send me a message or whatever message. And I hope you've learned something today. And before you end, please make sure that you indicated your attendance, LMS, and then I would like to talk to the ratio. So that ends our session. See you next meeting, which is on Tuesday. And so we'll have our meeting, 2 meetings next week, which is next week, which is next week, which is April 26 and April 29. And then on May, first week of May is your holiday, right? You still have your sem break. So after malanganin ka sa chapter 10. So we just have, pwede naman mo. So we'll continue chapter 10 on 26, and I actually would like to start another chapter by 29. Okay, should be on alcohols. Dapat mahuman na sa radicals on Tuesday, and then supposedly you have your academic break, but I would like to start another topic, which is alcohol. So before kana kumahuman na to ang radical reactions. Okay, so that ends our session today. Ora to. And goodbye. Except Rachel. Yes, do you have questions? Na record na ako ni, my God, wala na ako na record.